All right, so we're going to be graphing two variable inequalities. We're going to graph two types. We're going to graph lines and exponential. So let's first focus on lines because they're the easiest. The first thing that you want to do is you want to change your form to the y is equal to mx plus b form. You can easily find the slope and the y-intercept. If you don't want to do that, that's fine, but that's the easiest type. Once you determine kind of where your slope is, you plotted a few points, right? You're going to determine the type of line you're going to graph, right? Are you going to graph a solid or a dashed line? Well, you have a dashed line if you have a less than or greater than symbol. So a dashed line is almost like an open circle when we are graphing on a number line. So that means no point, no ordered pair will be a solution to your inequality, hence it's dashed. If you have an inequality that looks like these two, greater than or equal to or less than or equal to, then we have a solid line, and every point of the line is a solution. So you'll be given a true statement when we test that out. But those are only a few types of solutions, or in the first case, there's no solutions. So how do we determine the rest? And that's shading. We have two types of places that we're going to shade. We either going to shade below our line, so we either have a less than or equal to symbol, or we're going to shade above the line, greater than or equal to. Again, sometimes this can be a little confusing. We're not exactly sure where above the line and below the line might be, right? So the best piece of advice I can tell you is test a point that's not on a line to determine where to shade, okay? I like anything that has zeros in it, either X's or Y's. 0, 0 is my favorite point to test. It's the easiest one. So pick a point that's not on the line to help to determine it. So let's go ahead and let's try our very first example. All right, so y is greater than or equal to negative 2x plus 3. So it's already in the y is equal to equation. So I already have my slope, which is negative 2. So I'm going to go down 2 over 1. I have my y-intercept, which is 3. This is telling me I have a solid line because there's a line here. Best piece of advice to kind of remember it. A solid line has that line. If it's missing the line underneath, then it's missing pieces. So I've already actually drawn my line for us, right? So there's my y-intercept, went down 2 over 1, down 2 over 1. So a greater than symbol means I'm going to be above my line. So above my line is going to be somewhere over here, okay? So I'm gonna do two test points. All right, so my first test point is on the line. So I want to make sure that I was correct in making sure my graph is a solid line. So I'm going to test the point 0, 3. So I should get a true statement for that. So 3 is greater than or equal to negative 2 times 0 plus 3. So I'm going to get 3 is greater than or equal to 3. So 3 can't be greater than itself, but it can be equal to itself, which means that this is going to be a solid line. So now I want to figure out where am I shading. So I'm shading everywhere over here. So you can tell 0, 0. My favorite test point is not included in this. Now I can test this and make sure that that's a false statement, which means I'm shading over here, but that's a little bit more, can be confusing. So I'm going to pick a point on this line. So I'm going to pick this point right here. So 1, 2, 3. So I'm going to test 3, 0. So 0 is greater than or equal to negative 2 times 3 plus 3. So negative 6 plus 3 is negative 3. So 0 is, in fact, greater than negative 3. That is a true statement. So I'm going to shade. So notice that my line goes through the entire portion of the grid that I created. And so when I shade, I don't like to make it dark because I want to be able to read every point. I should be able to say this is a point and a solution to this inequality. This is a point and so forth. So how I shade, which will also help us when we're solving systems of inequalities, is I just make just straight lines. Right? So I know all my shadings over here. I can easily tell where I shaded. I can easily read any point that's on here. I want to try to limit myself or try not to limit myself. I want to make sure that I extend my line, because if I only graphed it up to here and I didn't shade down here, I might not think that that's part of my solution. Okay, so let's try another one. So we have y is less than, this time, negative 1/3 x minus 1. Again, it's already in the y is equal to position. We have a less than sign, so we should have a dashed line. Negative 1/3 x, or negative 1/3 is our slope. Then we have a negative 1 as our y-intercept. So again, I've already graphed it for us to save a little bit of time. So here is our graph. So there's a negative 1, go down 1/3. Notice that it's a dashed line. So I'm going to just double check that that point's not going to ever be a solution. So I'm going to test the point, and that point will be 0, negative 1. So negative 1 is less than negative 1/3 times 0 minus 1. So this is what I'm talking about. Negative 1 cannot be less than itself, which means all of these solutions will not be answers. Okay. So now I want to figure out where I'm going to shade. So it was a less than sign, so I should be below my graph. Again, 0, 0, my favorite test point's not included. I did that purposely. So I'm just going to pick a point. And so I'm going to pick a point on this line. So negative 1, negative 2, negative 3. So let's test the point 0, negative 3 and see if that works out. So this will be negative 3 is less than negative 1/3 times 0 minus 1. So this will be negative 3 is less than negative 1. Negative 3 is, in fact, smaller than negative 1. That works out. So that means I'm going to shade all over here. Again, notice that I have arrows on my graph, on my line. Notice that I can easily read any point. And I could have picked any single point to test. Again, I like to pick numbers that will make my variables disappear. So I like to pick them with zeros in them. Okay, so I want you guys to try the next one on your own and make a test point. Doesn't matter what that test point is. Okay, pause the video if you need extra time. So we have y is less than or equal to 4x plus 2. All right, hopefully you paused the video and you tried this one on your own. Okay, so it's already in the y is equal to form, and so we should have something that kind of looks like this, right? So positive 2, I'm going to go up 4/1. I could go down 4/1 the opposite direction. It is a solid line. Again, we could have tested that point out. I did not try that. But we have less than sign, which means that we're going to be below our graph. So here's below our graph. My favorite point, 0, 0, is included in that less than. So you can see over here, I tested that point out. 0, 0, so 4 times 0 is 0. 0 plus 2 is 2. 0 is indeed smaller than 2. That worked out. So I know that this is where all my shading is going to lie. So that means that this is a point, this is a point, this is a point. Every single number over on that side is a point. So let's go ahead and try one more. So 2x minus y is less than 5. And pause the video if you need help. All right, so the first thing I'm going to do is I'm going to change the form. So I actually switched the y and the 5. So I added y and I subtracted 5. So it's going to look something like this. So 2x minus 5 is less than y. But then I'm going to put it in the y is equal to. So I always like my y on the left-hand side. And when I do that, notice that the inequality is still opening up towards your y. So the inequality is still opening up towards my y. 2x is still positive, 5 is still negative. So it is a greater than symbol. Okay, so this is where sometimes that initial symbol can be kind of confusing. Okay, so I have my y-intercept at -5. I have my slope at 2. So I'm going to go ahead and plot that. So down -5, up 2/1, up 2/1, so forth and so on. dashed line because in the original problem, we didn't have a line underneath. So notice that the original problem had a less than symbol, but notice that we're shading above. So if you had moved the 2x over to the other side, we would have had a negative y. We would have had to divide by negative 1, which would have flipped our inequality sign. I did not do that in order to find my answer. I just flip-flopped where these two things, numbers and variables, were going to be. But again, I want to test a point. It just so happens that my favorite test point, 0, 0, was included. So you can see my work over here, 0, 0. So 2 times 0 minus 0 is 0. 0 is in fact smaller than 5. So notice that I plugged it into the original equation, or sorry, original inequality. I always want to plug it into the original inequality because I might have made a mistake somewhere along the way. So the original one, I haven't made a mistake because I'm just copying it down, unless you made a mistake copying it down. So again, this works, so I know I'm going to be shading above that line. All right, so those are your lines. So any other type of graph is going to look exactly the same as this. We got to figure out if it's going to be solid or it's going to be dashed. And then you got to figure out if it's going to be, we're going to shade above the line or below the line. So let's focus now on two more problems, and those are your exponential. So here's our next problem. So y is less than 2 to the power of x. Again, if you can't remember how we solve these problems, look back in your notes or just make a quick table of points. So I've already plotted a few points to kind of help us along the way. So if I plugged in 0, if I plugged in 1, 2, 3, 4, all that wonderful stuff, it looks something like this. We do have an asymptote at your x-axis. So here's the first one. So we have a less than symbol, which means that it's going to be dashed. So, I'm going to go ahead and dash it up. Again, draw little arrows pointing in that direction to the best of our ability. Now we're going to shade below, it says. So I want to make sure that this is a true statement. So I'm going to shade all below your exponential. So I'm going to test a point. Okay, so I'm going to test the point. Again, it looks like 0, 0 is in my test region. So let's test out 0, 0. Is 0 less than 2 to the power of 0? So 0 is less than 1. Is that a true statement? It is, which means all of this down here will be part of my solution. Okay, again, we could have tested any point along the way and seen if that is a true statement. Again, we can test the point, make sure that on your anything on your graph is not going to be a solution. All right, so let's try one more inequality with exponential. So I'll come down here. So last problem, y is greater than or equal to 1/2 x. So why don't you go ahead and pause that video and see if you get this correct. Okay, so again, I'm going to go ahead and plot some points. Again, here are some of my points that I plotted. This graph is actually it almost looks like the mirror image of this graph, right? Just on opposite sides. There is a line underneath your inequality. So that means I am going to connect all of them together in a solid graph. Okay, and so now I'm going to shade above, right? So above my graph is going to look like this. Oops. I want to make sure that my graph does not look like it's coming back around. Okay, so I'm going to test a point. Let's test out this point. Let's test out 0, 2. So test point 0, 2. So is 2 greater than or equal to 1/2 to the power of 0? Well, anything to the power of 0, we remember, is 1. So 2 is greater than or equal to, pardon me. 2 is greater than 1. That is a true statement, which means that my shading is going to be above my graph. So it's going to look something like that. Okay, again, we're going to see in our systems of equations, we're going to see them kind of two lines. We might see two exponential, we might see an exponential with the lines. So it's going to make life easier for systems if we graph and shade it like that. We'll see the crosshatch.